Couple of quick examples on that. If I want to integrate this thing, remember that integrating, we're allowed to just pull this thing apart into its individual pieces. So this integral is the same as integrating 2 cos x dx plus integrating 3 over x dx minus integrating root x dx. And we've just looked at what each of these three things is. Cos x, well, that one integrates to sine. So this is going to be 2 sine x. 3 over x, well, that's 3 lots of 1 over x, and we established that 1 over x integrates to natural log of x. So this is 3 lots of natural log x. And then root x is just a polynomial. This is x to the half. So we just do our standard thing here. So we're going to take away x to the 3 over 2 divided by 3 over 2. I'm probably going to tidy that up a little bit. And we mustn't forget our plus c. So our final thing is 2 sine x plus 3 natural log of x. And then dividing by 3 over 2 is the same thing as multiplying by 2 over 3. So this is, if I write that correctly, 2x to the 3 over 2 over 3 plus some constant. It's not super difficult, but you have to have memorized all of these other integration things, or memorized the differentiation ones and reverse engineered them. Okay, and part B, we're going to do the same thing. I can pull this apart into integrating cos x over sine squared x, take away the integral of 2e to the x. 2e to the x is pretty straightforward. We'll sort that out in a minute, but it's very easy. Cos x over sine squared x doesn't look very straightforward, but this is about using trig identities. So I can separate this up into cos x over sine x multiplied by 1 over sine x. So I want to integrate this with respect to x. And cos over sine is actually cot, and 1 over sine is cosec. So this is actually the integral of cot x cosec x. And if you just go and look at the list we've just made of 9 things, this is one of the ones that's actually in the formula book. This is one of the standard integrals. So this is just negative cosec x, and that's it. And integrating 2e to the x gives us, oh, a big surprise, 2e to the x. So the solution to this is negative cosec x, take away 2e to the x, and then don't forget your plus c. Okay, and the second example, similar work involved, separating it out into some standard integrals, but this time we have a definite integral, but the limits we don't know about. So there's a bit of a problem-solving aspect to this question as well. So let's just take this a step at a time. I have the integral between a and 3a of 2x plus 1 over x. Now, if I want to integrate that, it's worth noting that this is a fraction with 2 separate terms in the numerator. And what that means is I can just pull it apart into 2 separate fractions. This is the integral between 0 and 3a of 2x over x plus 1 over x. Oh, and that's actually quite nice because 2x over x is just x, is 2. Integrating 2 gives us 2x. And integrating 1 over x gives us ln of x, which we'd already established. Because it's a definite integral, I don't need to worry about the plus c, actually. I can sort that out in a minute. But this is between a and 3a. And I know that this equals ln 12, so that's going to be a part of our problem solving in just a minute. What I want to do is then substitute 3a and a in and subtract them and see where we get. So I am going to get 2 lots of 3a plus ln of 3a, take away 2 lots of a plus ln of a, and then this tidies up somewhat. 2 times 3a is 6a, take away 2a is going to be 4a, and then I've got ln of 3a, take away ln of a. And we have some rules that we can apply to do with logarithms, so that actually gives us 4a plus ln of 3a divided by a, because when you're subtracting, that's the same as dividing with logs. Oh, and the 3a's and the a cancel. So this is 4a plus ln of 3. And we know that this equals ln of 12. Okay, actually don't need my absolute signs there anymore because ln 3 is just a number. And that tells us that 4a is equal to ln 12 minus ln 3, which is equal to ln of 12 over 3, or ln of 4. And if 4a is ln 4, then I can just divide everything by 4, and then a is just ln 4 divided by 4. Or I think in the textbook it's written as 1/4 ln 4. They're equivalent. It doesn't really matter which way you write it. And that's it. A is 1/4 of natural log 4. And we dealt with that by separating out. So I had a couple of standard integrals I could use, and then applying the limits and doing some stuff with logarithms that we've covered all of that before. So there's nothing brand new and extraordinary here. It's just that we now have the ability to integrate a whole bunch of extra functions, and sometimes that means I can pull apart a function into small pieces which are easy, straightforward to integrate. You should have enough information now to have a go at exercise 11a.